So we know one method now for solving systems of equations, and that is graphing. And that's not always an accurate way, especially if you have big numbers, they go off your graph for different reasons. So we're going to learn another method today, substitution. And it is just what it says. We're going to substitute for one variable in terms of another. And this is a good one to use when you have one variable by itself or the coefficient of one of the variables is 1. So in this case, I know y is equal to 3x, so I'm going to take that, I'm going to substitute it in my other equation where there's a y. So it would say x plus 2, and now I'm going to make my substitution, replace that y with a 3x, equal negative 21. Now it's just a matter of solving. This would be multiplying, you get 7x equal negative 21. Oops, sorry, 6x here, working ahead. So x plus 6x is 7x equal negative 21. If I divide both sides by 7, I get x equals negative 3. Now remember, I'm not done because I want an ordered pair. So I can substitute this in either equation to find what the y would be. It would be easier to substitute it in this equation. So if I do that, I'm going to get that y equals 3 times, and in this case I'm going to replace x with a negative 3. So y equals negative 9. Make sure in the end that you write your answer as an ordered pair. So my solution would be the ordered pair, negative 3, negative 9. So after you find the one, you must substitute back and find the other. Again, in this problem, I notice that the x is by itself, so I'm going to substitute in the second equation, and it doesn't matter which one it is. Mine have just happened to be both in the first equation. So where there's an x over here, I'm going to substitute 4y. So it'll say 4 times 4y minus y equals 75. So 4 times 4y would be 16y minus y equals 75. So that would be 15y equals 75. So I need to divide both sides by 15 and to get y equals 5. So again, I need to substitute that back in here. I'm going to substitute it in this first one and get 4 times, and I'm substituting in a 5. So I get that x equals 20. Now make sure you get them in the right order. The x term, remember, comes first in an ordered pair xy. So 25 would be my ordered pair. Now in this term, in these two equations, neither variable is by itself, but the x here has a coefficient of 1 in this equation, so I'm going to isolate it and get it by itself by subtracting 5y from each side. And here, since it doesn't really matter what goes first, I'll just write negative 3 minus 5y. So now in the second equation, I'm going to substitute that in place of my x, so it'll be 3 times the quantity, negative 3 minus 5y, minus 2y, equal 8. Now it's just a matter of going through and solving that. So when I distribute, I'm going to get negative 9 minus 15y minus 2y equal 8. I'm going to simplify on this side first and get negative 9 minus 17y equal 8. So now I'm going to add 9 to each side and get negative 17y equal 17. And if I divide by negative 17, I get y equals negative 1. So now I'm going to substitute that back in. You can substitute it in any equation that you want. So I guess I'll substitute it in where we've already done some work and get that x equals negative 3 minus 5 times, and I'm going to put in a negative 1. So this would be negative 3, negative times negative would be plus 6. So we'll get that x equals 3. Oops, sorry, that should be a 5, so x equals 2. So your ordered pair is the ordered pair 2, negative 1. And again, make sure you write your answer as an ordered pair. And in this problem, again, we have the second equation now solved for y, so I'm going to use that and substitute in my first equation. So it'll be 6x minus 2, and I'm going to replace the y with this whole thing. 3x plus 2 equal negative 4. So now I'm going to distribute a negative 2 and get negative 6x minus 4 equal negative 4. Well, 6x minus 6x is 0, so I'm left with negative 4 equal negative 4. That is a true sentence, so that means, in this case, not all numbers, but there are infinitely many solutions. So you would write infinitely many.